Hello and welcome to my new video. This time, Charlotte's friendly AI voice tells you about my adventures with the new IP adapter weights nodes and Animate Diff. When I was experimenting with the stable video diffusion model a few months ago, I of course also looked at the possibilities of Animate Diff. However, my results were perhaps amusing, but anything but satisfactory. So I no longer bothered with the technical side of Animate Diff. But then, a few weeks ago, the creator of the IP Adapter Plus nodes, Matteo from the YouTube channel Latent Vision, published new nodes. I'm not usually one for exaggerating, but it's appropriate here. The new IP Adapter weights nodes are simply phenomenal. I've spent the last 2 weeks trying to figure out how to use them with Animate Diff. And the level of control and creative application possibilities is so great that I decided to turn it into a video series. Even the basic workflow presented by Matteo is already filled with a variety of control options that produce really cool results, even without additional control nets and other methods. However, the amount of resources and time required to generate the moving images is quite massive. That's why I decided to rely largely on LCM. You can install all the necessary LCM nodes and models via the ComfyUI Manager or download them from Hugging Face. If you don't want to follow my LCM strategy, you can of course also use the usual nodes for sampling. The setup is as follows. First, we need the usual checkpoint node. At Civitai, you can download Stable Diffusion SD, 1.5 models that already have LCM integrated. The model I use the most right now is Absolute Reality LCM, but there are others, also from Dreamshaper. If we want to follow the model pipeline, then the next node is already the Use Evolved sampling node from Animate Diff Evolved. We then connect this to the Context Options Standard Static node and the Apply Animate Diff Model Advanced node. We can also connect the motion model to the latter via the Load Animate Diff model. We then connect the IP Adapter Unified Loader to the model pipeline. And we connect the loader to two IP Adapter Batch Advanced nodes. The last of these then only needs to be connected to the K sampler. So far, so good. As I am using the possibilities of LCM, we need a sampler custom node here. We connect the LCM scheduler to this via the Sigma inputs and outputs, and the sampler LCM cycle node. Only the VAE decode and the load VAE node are missing from the sampler. And of course the empty latent image node. Back to the IP adapters. Here we need two image loaders and, if required, two prep image for clip vision nodes. I always add them simply because they provide further useful options as far as the source image is concerned. We attach these to an image batch multiple node. From which it then goes to the new IP adapter weights node. We link its weights and weights inverted outputs to the first and second IP adapter batch nodes. Weights into the first and weights inverted into the second. The image 1 and image 2 outputs work in a similar way. Connect the batch size of empty latent image to total frames once we have made it an input. We then connect the weight strategy output to the next new node. Prompt schedule from weights strategy. This leads us to the batch prompt schedule node. For additional prompt inputs, we can then create a text field with a primitive node and connect it to app text. Now we just need to connect total frames to max frames from the IP adapter weights node. Then connect the positive and negative prompts to the sampler, and we've now made it. In the sampler LCM cycle node, you can add more cycles to the generation without having to exceed the K-sampler's total steps of 10. If you select the setting true for tweak sigmas, this can help to optimize the processing of image noise in the K-sampler or custom sampler. Ancestral also adds the influence of this sampling method to the Euler steps. That is, more image noise is added per sampling step, which can sometimes lead to more creative results. Here too, you have to try it out. In the sampler custom node, my tests have shown that the add noise setting can remain set to true. Here too, the motto is, the more noise, the better. The new IP adapter weights node lives up to its name, as the values set here actually have the greatest weight when controlling the content of the generated videos. IP adapter weights and prompt schedule from weights strategy form a single unit. This means that the values set in the weights node have a direct effect on the content display of the images in the finished video. Values of 1.0 and above give more weight to the IP adapter, and values below take more account of the prompt. Depending on how many source images are connected to the image batch multiple node and the corresponding prompts in the weight strategy node, a value can be assigned to each of them. This allows you to specifically influence the interaction between the prompt and the adapter. In the weights node itself, you can use the frames option to set how many total frames the video should have. However, this value increases quickly if you add additional frames via add starting frames and add ending frames. With these three values alone, you already have a huge amount of influence on the video generation. In my experiments with this basic workflow, only the alternate batches setting worked well. The others are probably intended for more complex workflows. I was somewhat surprised by the timing option. This allows you to influence how the individual images behave when they appear and disappear. Together with the weight type settings in the IP adapter batch nodes, this causes the objects in the image to come towards you if you select the ease-in option, for example. The two batch nodes also give you further options for controlling the source images. In order for the source images to become motion pictures, they must be brought into motion by the Animate Diff nodes and the connected models. This is where the various Animate Diff evolved nodes come into play. These can also give you a whole range of options for influencing them. On the one hand, via the selected model itself, I prefer to use the Animate LCM model as a motion model, but I also tried out the others. You can see all the results of this series of tests in the uncut version of the video if you like. In the Use Evolved Sampling node, you can select the different schedulers under Beta Schedule, but you have to make sure that you select Stable Diffusion 1.5 compatible. Unfortunately, these cool things are not yet available for SDXL, so they are not an option for the time being. The Context Options Standard Static node gives you even more control over the generated video. However, you should leave context length set to 16 because the motion models of the second version do not yet process longer ones well. Experimenting with context overlap helped a lot in my attempts to generate a coherent video from the content of the two images from the IP adapters. But you get the actual control over the movement via the Apply Animate Diff Model Advanced node. You can connect motion laws to this and exert direct influence on overall or partial aspects of the animation in numerous ways. Scale multi-values, effect multi-values, and add keyframes are responsible for this. In addition to the direct setting of values, the start, strength, and end of the animation can also be specifically influenced. This works via color gradients, or rather gray gradients. The general rule is, black means that there is no movement, and white means that the maximum movement is used. The things you can do with these masks alone would need a video of their own. You can also follow my learning process in the uncut version of the video if you want. This brings us to the end of the first part of my series. The other parts will be about dealing with the resource problem. If you don't have an extremely powerful computer at your disposal, your computer will certainly go to its knees with 110 frames. That's why I've added 2 more steps to the workflow. One to generate many images in the first step with low resolution. A second to improve and upscale these images using Perturbed Attention Guidance, and a third to generate longer, more stable and high-resolution videos from them. And another video will be about integrating other methods, such as control nets into the workflow, and above all, trying them out. For me, working with the combination of IP adapters and Animate Diff Evolved is still completely new, and a really exciting learning process. If you found the video interesting and/or helpful, I would appreciate a like and a subscribe. Thanks for watching. And last but not least, have a great day.